Question 20. We are given three values, x is 3, y is 8.37, and z is 5.3, and we are told that these values are correct to certain measurements here. So the fact that we have been given values correct to a certain significant figure or decimal place, combined with this mention of upper or lower bounds here, tells us we're dealing with limits of accuracy, tells us we're dealing with upper or lower bounds. Now, as soon as you have that, the first thing that you can do is you can find the upper and lower bound of every single number that's given. Now, whether or not you need the upper or lower bound of every single number that's given, my advice would be don't overthink it, just find the upper and lower bound straight away. So 3 rounded to one significant figure, the number that would come before it is 2, and the number that would come after it is 4, that is also rounded to one significant figure, which means that our upper and lower bounds in here are going to be 2.5 and 3.5 respectively. So I'm just going to list the fact that our x's, the upper and lower bounds are 3.5 and 3.25. For our second number, 8.37, correct to three significant figures, before that would be 8.36, after that will be 8.38, and our values for our upper and lower bounds in between that are going to give us an 8.375 for the upper bound and an 8.365 for the lower bound. And last but not least, 5.3 to one decimal place. The one decimal place answer before it and after will be 5.2 and 5.4, meaning that our upper and lower bounds are going to be 5.35 and a 5.25. So marks in the bag straight away for finding all of the upper and lower bounds. Now, the question itself, or the formula that we're going to be interested in, is x bracket y minus z, and we are looking for the upper bound of it. So we're looking for the largest possible answer for this expression here when we substitute either the upper or lower bound of each of the following numbers. Now, looking at what's in blue, if you're not sure which upper or lower bounds to substitute in, then basically sub in every single possible combination. So you could sub in upper, upper, upper into this formula, get an answer. You could sub in upper, upper, lower. You could sub in upper, lower, upper, upper, lower, 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 upper, upper. The point I want to make is that if you try every single possible combination, then what will happen is one of those answers will be the biggest possible, and the biggest possible will be our upper bound. All right? But if, of course, you have an idea about which number should go where, then that's preferable. But the only reason I mentioned what I did before is because you have a guaranteed way of finding the answer to this if you try every possible combination. So, in terms of how you would be able to figure this out without trial and improvement, basically, you have a multiplying sum here in red, which means we want the biggest possible values either side of that multiplying sum. So that means we're going to want the upper bound of x, and we want the upper bound of the bracket first and foremost. So we've got the upper bound of x straight away. I know I'm going to be wanting 3.5 from that. As far as the upper bound of the bracket is concerned, that is a subtraction sum. We have a y, take away a z. In order for that answer to be as big as possible, we are going to want the biggest possible y, and we are going to want to take away the smallest possible z. So what we end up with here is we have the 3.5 on the outside of the bracket. We're going to have an 8.375 on the inside of the bracket for y, along with a subtract 5.25. So just to highlight all of these, pick a different color. We have our upper bound for x here, because of the fact that we want that value to be as big as possible. We have our upper bound on the inside for y, subtract our lower bound for z in order to make the answer from inside that bracket as large as possible. We type down in the calculator, we are then going to get 10.9375, which is the largest possible answer for combining any of these in this formula. Done.